Afternoon. How are you doing? Can you hear me? Okay. My name is Guilherme Bueno. I'm a civil engineer. I currently work for Vergraph. I provide consultancy services, support for structural calculations, and today I'm going to be speaking about the main applications and some properties of composite rebars reinforced with glass fiber and graphene. Vergraph is producing meshes and rebars. In the future, we're going to have more solutions that are currently under development. The composition of our materials can be seen in this slide. At the core of the rebars, we have glass fiber, and involving these fibers, we have a polymer matrix, and that's where we use graphene. We have some products being traded currently, and we produce rebars, as I mentioned, with the same diameters as steel. For smaller diameters, up to 10 millimeters, we can provide them in rolls of about 100 meters. For larger diameters, 32 millimeters, we only have the straight bars, 6 or 12 meters. And then we have meshes or grids. Same standards as steel, 10 by 10, 15 by 15, or 20 by 20 centimeters. 2 per 3, 245 per 6, and also we manufacture rolls, 3-meter rolls, 3 meters per 100 meters. These are the rolls. Here you see an image of our products in our industrial plant, which is located 100 kilometers from São Paulo, in the city of Cambuí, already in the state of Minas Gerais. This is a PDF file, so there's a video here which we cannot watch right now. And in this video we see how easy it is to unroll a mesh. It's a 3 meter per 100 meter mesh or screen. In about just 10 seconds after you handle the material, in about 10 seconds it is completely set up. So for a construction site, that reduces the amount of people necessary to set up the mesh, and it also increases productivity. Composites, fiber reinforced composites, they were developed because of durability. As you all know, steel is subject to corrosion. If we don't reinforce our structures, they might collapse. So in order to repair and reinforce them, that will mean money for maintenance purposes. So composites appeared as an alternative to avoid these problems connected to steel corrosion. The metal meshes, when they suffer corrosion, there is a reduction in adhesion to concrete. And this reduction might compromise safety. There might be fissures in the concrete piece, and these fissures increase if there is no maintenance. This structure will collapse. So that is why composite rebars were developed, fiberglass reinforced. Here you see the physical structure. You have the core with the fibers, and we have different types of fibers and resin. Fibers are meant to resist, to give mechanical properties to the rebar, and resin absorbs strength and transfer this to individual fibers. As I mentioned, we have different types of fiber available in the market. So we have glass fibers, carbon, aramid or basalt. The main fiber used in the market because of its cost performance ratio is glass fiber. Composites with glass fiber, they have strength that is 2 times that of steel. Here you see the structure of rebars, Vergraph rebars. In the polymer matrix, we incorporate graphene, graphene is, well, we receive graphene dispersed in a liquid, and we incorporate it into the resin. It comes diluted to us, and we mix it into the resin. It is 200 or 300 times stronger than steel. It is very thin, and that allows us to incorporate it in our resin. So its strength, its resistance is very high, and it can improve the properties of composites, mechanical strength, thermal resistance, resistance to UV rays, radiation, the production of rebars and meshes by Vergraph. This is done by a pultrusion process. In this process, fibers are in rolls or roofings. And then they go into a bath with a polymer, the resin. And at this point, we already have graphene incorporated.
At the end, we're going to have different shapes like the rebar, the mesh, the stirrups, and folded parts that will be in the market as of the next year. And after molding, we have the curing process within or inside an oven, and then the product is cut and stored to be sold. FRP composites, so fiber reinforced polymers, are around 2 to 3 times more resistant to traction compared to steel. They are not subject to corrosion, which leads to a more durable structure, and this is the main reason why these materials have been developed. They're very versatile, can be used in different types of constructions, with or without infrastructural purposes. And as to the composition of these materials, they are an alternative to steel, and they are 4 to 5 times lighter than steel. In this graph, you can see the increase in the use of rebars in the 90s in the US. And that's when the first project guide was launched in North America for dimensioning and application of fiber reinforced rebars. And the increase of almost tenfold in several types of construction with infrastructural or not, purposes or not. And the estimate, at least provided by a North American Research Institute, says that only in North America the demand for rebars made from fiber reinforced composites will be twofold in 5 years. In this table, you can see a comparison between properties of steel and the ones that are required for rebars according to the standards, and also the graph properties. The tensile strength of steel is between 450 to 500 megapascals, and that's the CA50. The standard requires fiber reinforced rebars to have a tensile strength of 800 megapascal. And Vergraph rebars, they on average have 10 megapascals. As the modulus of elasticity, current guidelines say 40 gigapascals, and we have almost 52 with our product. Density is approximately 4 times lighter compared to the density of steel. The adherence is similar to concrete and metal rebars, and these composites do not conduct electricity or magnetism, so they can be used, for example, in MRI rooms in hospital with no interference. And if you use steel rebars, there is some interference. So some hospitals in the US already use these specific applications in rooms where they have equipment for MRI. As to electric conductivity, in Brazil, some companies that work with pre-molded posts have already tested this application to validate it in posts, because it's a type of structural element that can have part of its structure exposed and is manufactured to hold electric cables. So if you have parts that are exposed and someone touches it, or we may have situations where electric transmission can happen that can lead to a fatality. Rebars made of composites do not conduct electricity, so they need less maintenance because the posts will be more durable, and we don't have the risk of corrosion, and we won't have the conduction of electricity if we have exposed cables. So this is another potential application. We are testing several properties, mechanical strength, and others at Federal University of São Carlos in the Structural Systems Lab in collaboration with Professor Civil Engineer Glaucia Tomofré. What you see here is a rebar in the test equipment to determine which are the properties that we should measure. And these are some of our findings in rebars and meshes regarding mechanical properties. Tension, the standard requires 800 megapascal, we have tested, and all tests reveal values higher than 1,000, 2015 on average, so much higher than required. In this column, we can see the modulus of elasticity with values also higher than what is required. Our average is around 52 gigapascal. And here at the bottom, you can see the tests done with meshes. So the woven direction, and we have also tested the secondary direction to determine what will be the tensile strength and if there are any losses due to the fact that the material is woven, because we are moving away from the longitudinal orientation that we see in rebars. And we wanted to know if the fibers, because they're woven, would be less resistant. So we tested this in our meshes, and the values on average are also around 1,000 megapascal. Hence, we're still above what the requirements are, or we are above the requirements, and we have a very good tensile strength compared to steel CA50. Model of elasticity was around 50 megapascals or gigapascals also. As to the behavior of this material within a structure that may catch fire, this has been tested at a Canadian university, and this article has been published showing the findings of this test, and this is the Composite Structure Journal. And you can see the summary on the screen. They've used the Canadian standard for structural elements with fiber reinforced rebars and meshes, CSA 206, so it has been updated in 2021 for the last time. And here you can see what they tested. The lengths that they used, the curve fire. We have two curves for that. The most commonly used is ISO 834 or ASTM 119 with different curves depending on the type of fire we are dealing with. So curves for residential fires above 1,000 Celsius, and that's the Q that was used in this test. This is a description and a representation of the oven. On the top is the structural element to be tested according to the Canadian standard, and at the bottom is where we have the fire. So it's like a fire in an apartment at a lower level, so we can measure on the upper portion of the structural element. That's where we measure temperature to see what is the temperature range and if it's according to the standard. So when the element will lose the ability to resist strain and will lose stability. And in the upper portion you can see the elements and the fiberglass reinforced rebars. This is the curve for fires in residential areas. Normally in an apartment or a house, a fire will reach 700 Celsius due to the materials and fuels that we have. We may have wood, we may have gas and electrical appliances. And this standard, this curve, has a safety coefficient, and the temperature is a little bit above 1,000 Celsius. Here you can see the structure after the test, showing when the stability was lost. And here you can see the conclusions of this study, this experimental study, showing that this structure with rebars and meshes made from fiber reinforced polymers, according to the Canadian standard, if exposed to SMS 119, subjected to more than 1,000 Celsius, lost stability after 3 hours of testing and reached the target temperature. So the time of fire resistance, this structural element, including composite meshes, was able to hold its properties for more than 3 hours, 180 minutes, and that's according to the requirements in Brazil for buildings and houses or buildings with more than 20 floors. So that would be enough for those inside this building to get out in case of a fire before the structure collapses. Globally, there are standards to measure this type of material and also specifications that the product has to satisfy or meet. The first guideline was ACI in the US in the 90s, and then in different countries and continents this was disseminated, and now we have a project guideline from Canada. We have one in Italy, Japan, Russia, and the global ones, ISO and STM. In Brazil, in November 2021, the ABS, the Brazilian Association of Engineering and Structural Consultancy, and IBRACON, Brazilian Concrete Institute, the practices recommended to determine the specifications these materials have to satisfy. So I was part of the committee in charge of developing this guideline, and this was based in international standards. This was published in November 2021, and the same team who prepared this material started to contribute to ABNT, which is sort of a continuation of this guideline with some modifications and some advancements. So as of March 2022 and up to May 10th, 2024, ABNTs were written, one for product specifications and another one for structural dimensioning. And this text was concluded on May 10th, 2024. And you can see here the title of the standard. This is for products called fiber reinforced and polymer bars or rebars for scaffolds made of concrete, and comprises 11 paragraphs describing all the properties that the material has to offer, shear strength and everything else, and the tests that have to be used to characterize materials. And this is a different standard that's going to be a single document for structural dimensioning, so that's what you need to adhere to project your structure. Fairgraph is a member of the ABFIBRA, an association that certifies products that are being introduced into the market, and there are stamps that guarantee that the products are according to the norm or standard. These materials can be applied in several different industries, and this has been going on for a long time, from elements that are not structure all the way to infrastructural constructions. And I would like to show you some examples before I conclude, to show you which are the current applications. That's the history of this material. So 50 years already, 50 to 70. The first project guideline was published in the 90s only. But long before that, the material was being developed and used, so almost 70 years ago. So there's a lot of history, a lot of background. In some examples, as you can see, the images are according to ACE standards, so applications in hospitals. This hospital in Texas is specifically for MRI. And since the material doesn't interfere with the waves in this equipment, it's a potential application. Also in tunnels, bridges, roads, industrial floorings, foundations, technology institutes, shopping centers, or shopping malls. And this is in countries like Germany, Russia, Japan, and also in the European continent. And these are the bridges in Canada. They don't use steel. They always use fiber rebars to have more durability. And in Canada, in the US, and in Europe, they have snow. So in some areas, they cover the bridge with ice so that the ice can melt. And this salt tends to be aggressive to the concrete, leading to corrosion. So they are using this material instead of steel, and this is an alternative to prevent corrosion. And these are other examples. Train lines in Europe, Switzerland.
And these are facilities in coastal areas. Here you see this barrier, this coastal barrier. Foundations in Germany, water and wastewater treatment stations. This is 100% reinforced with fiberglass rebars. This is in Canada. You see the side walls, the top part, and here you see the whole structure, diameter between 15 and 20 millimeters. These are subway structures in Germany. This is a residential building in Switzerland, and also runways in airports. In the US, some highways have this rigid pavement. Here in Brazil, we have a different solution, but abroad it's rigid pavement. So they used reinforced steel with fiberglasses. In Brazil, we have some construction works. I know I'm out of time and I'm about to finish. So we see meshes, resistant with tensile strength for concrete structures. This is prefabricated. Some prefabricated companies or companies that provide prefabricated structures, they are opting for fiberglass reinforced structures. Households as well. This is an architecture show in Novo Hamburgo in the south of Brazil. It's a show that takes place every year. And every year they show different houses that are built for the show. Then they demolish the houses and they build them again for the following year. And they are using glass fiber in the foundations, in structural elements. This is a modular home, but the foundation, all the pillars, all the support, slab is done using fiberglass. This is a company that is producing ceiling panels. On the left-hand side, this is a panel that is going to be used to set up a ceiling wall. Pre-molded bars or rods. These are These are prefabricated and then they are taken from one city to another. That's where the house was assembled. And 90% of the reinforcement was done with fiberglass, rebars, and meshes. The main application for industrial flooring is the one that you see here. It's a double structure. It's 10 tons per square meter. That's the strength applied here. Once again, this is the architecture show, and this is the show that took place in 2023. This year, they're not going to have this show because this state, Rio Grande do Sul, was heavily flooded this year. But this is the image from last year's show. On the left-hand side, you see a modular household. And all the pillars, the foundation, this is done with fiberglass material. And on the right-hand side, you see the reinforced concrete with fiber. It doesn't look like concrete, right? Like reinforced concrete. But it is reinforced concrete with fibers. Same thing here. These are industrial warehouses. Flooring solutions, the slab, and one single person handling this can raise the mesh. If this was a metal mesh, it usually takes 2 or 3 people to handle them. So it's more ergonomic. It's 5 times lighter, the fiberglass. And you need less labor to set up the structure, which increases productivity in the construction site. This is a flooring solution. It's the entering of a parking lot, industrial warehouses. This is a hydropower plant, and you can see all the contention walls, the protection walls. They need a lot of protection walls along the roads. There is now a construction company in Brazil that will now refurbish a highway. And in one of the parts of this highway, they're going to do the first test with a soil similar to that in Brazil, using fiberglass composites. These are concrete posts. They used to be done with steel, but we have already conducted some testings to validate tensile strength. And we have validated this prototype. So if you have electricity cables, in that case here, there is no risk of shock or having contact with the exposed material because composites do not conduct energy. Another type of use is for support structures in agribusiness. These arcs for greenhouses, which could suffer with corrosion, they're now being replaced by fiberglass material. We have to make these folds in the production process. If we don't have a folded piece, we can mix it with steel. We can use this cross-sectional structure, the grids, or we can require the manufacturer to produce foldable pieces. And we can tie it with conventional material, with regular wires. Or we can use also nylon. We can cut this with this type of scissors, industrial scissors. And that allows us to also cut the material. As for logistics and freight or transportation, Since this material is very light, for SUVs can transport this material. This is a roll, a 300 square meter roll, 3 meters per 100 meters. That's the size of the mesh, the roll of the mesh. 2 people handling it, it's 300 square meters again. And at the bottom, you can see the rebars in a roll. That is equal to 9,000 meters of rolled rebars in the back of a small SUV. So transportation and handling at the construction site is very easy because the material is extremely light. These are references of some standards for structural dimensioning purposes. And I also show you some images that are not vergraphs. They are from scientific work. And here you see the list of reference because I want to mention the authors of these works, where the data comes from. These are not from vergraph reports. And finally, here you have our social media channels, Instagram, LinkedIn, our website. Please follow us online. We are constantly publishing new applications and new construction sites where we have our solutions being applied. Thank you very much for your attention, for your interest. And I'm available if you have any questions, comments. I know I'm out of time, but I will be available at our booth. It's the AB Fibra booth. Right around the corner to the left. So if you have any questions, you can come to our booth. Thank you very much once again.